Welcome everyone. In this walkthrough we'll look at electrochemistry. The question is taken from an A-level past paper. Details are in the description. The question is divided into small 1 and 2 mark sections, so lots of marks here for knowing short key facts and ideas. Let's get started. A student set up the cell shown. The student recorded an initial voltage of plus 0.16 volts at 25 degrees Celsius. Explain how the salt bridge provides an electrical connection between the two solutions. The salt bridge might be a glass tube containing a solution of inert ions, so the salt bridge completes the circuit because it has mobile ions. Here's the next part of the question. The standard electrode potential for the Cu2 plus Cu electrode is plus 0.34 volts, and we're given the reduction half equation. Calculate the electrode potential of the left-hand electrode in this cell. Standard electrode potentials are measured when a half cell is connected to the standard hydrogen electrode under standard conditions. Any gases present must be at a pressure of 100 kilopascals. The temperature must be 298 Kelvin. The concentrations of aqueous ions must be 1.00 moles per decimeter cubed. The values of electrode potentials are linked to equilibrium position. The greater the electrode potential of a half cell, the further this equilibrium lies to the right. Changes to concentration and temperature impact the equilibrium position and the value of electrode potentials. The right-hand cell has standard conditions, 25 degrees Celsius and 1 mole per decimeter cubed of Cu2 plus ions. The right-hand cell has a greater concentration of Cu2 plus ions. This equilibrium will lie further to the right and have a greater potential difference. E cell is equal to the electrode potential of the most positive electrode, subtract the electrode potential of the most negative electrode. Substitute the values given in the question into this equation. The electrode potential of the left-hand electrode works out to be plus 0.18 volts. Next, we have to state why the left-hand electrode does not have an electrode potential of plus 0.34 volts. This electrode would have an electrode potential of plus 0.34 volts under standard conditions. However, the left-hand electrode does not have a concentration of Cu2 plus ions equal to 1.00 mole per decimeter cubed. Next, give the conventional representation for the cell. Include all state symbols. In standard cell notation, a single line represents a phase boundary. That would be a boundary between a solid and a gas or a solid and a liquid, etc. A double line represents the salt bridge. The oxidation electrode goes on the left, the reduction on the right. Commas separate different species in the same electrode in the same phase. The conventional cell representation is given in blue. This is an unusual example because both half cells contain Cu2 plus ions and a solid copper electrode. And here's the final part of the question. When the voltmeter is replaced by a bulb, the EMF of the cell decreases over time to 0 volts. Suggest how the concentration of copper 2 ions in the left-hand electrode changes when the bulb is alight. Give one reason why the EMF of the cell decreases to 0 volts. When the bulb is alight, the copper 2 plus concentration in the left-hand electrode increases. Over time, the copper 2 plus concentration in both the left-hand and the right-hand electrodes become equal and the EMF becomes 0 volts. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.